In this section 12.5, we're going to learn about permutations and combinations. And at first, it's going to seem really weird. And then you're going to really, once you practice it, I think you're going to find them very easy. And your calculator actually has functions to work with these. So first, let's introduce some basic stuff to help you learn this section. First of all, we have this fundamental counting principle. Now, what the fundamental counting principle says that if you have several ways, m ways to do something, and you have n ways to do another, there are m times n ways of doing both. It's the product. So we use these in a lot of questions about, for example, you have 3 shirts and 4 pants. How many outfits? So there are 3 shirts to pick from, and there are 4 pants to pick from. So altogether, you're going to have 12 different combinations or outfits that you can make from those 3 shirts and 4 pants. So same thing if you go to an ice cream store and there's 6 flavors, okay, and there's 3 cones. And we say, well, how many different kinds of ice cream can you get? Well, 6 flavors times 3 cones is 18 different types of combinations that you can get for your ice cream. The second thing we have to introduce before we move on to permutations and combinations is we need to understand what a factorial is. Now, the definition is very confusing. It says for any positive integer n, the product of the integers from 1 to n is called n factorial and is written n with an exclamation point. So as an example, 3 factorial is equal to 3 times 2 times 1. So basically the number times each integer that came before it. So 5 factorial is 5 times 4 times 3 times 2 times 1. Starts with 5 and goes down to 1. 10 factorial, same idea. Starts with 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. You'll be happy to know that this product is huge, but your calculator actually has a function, and you type 10 factorial, and it actually multiplies it all out, okay? The only rule you want to remember, I guess tricky rule, is 0 factorial, and that one always equals 1. That's just something you're going to have to memorize. So how do we use these? Well, first of all, let's talk about permutations. And a permutation is an arrangement of objects in which order is important. So in other words, order matters. Okay, so when order matters, we use the idea of permutations. Now, we start out, for example, the number of permutations of n objects is given by, and then this is kind of how they write it. They say, okay, there's n objects. We're going to use all n objects in our order options. And how many orders can we have? Well, it's going to be n factorial. So, for example, let's say that we have the word cat, okay? And we want to rearrange all the letters of cat. So, in other words, there's 3 letters in cat. We want to use all 3. So the different number of combinations possible, or orders possible for those 3 letters is going to be 3 times 2 times 1, or 6 combinations for those 3 letters. Now, what happens if order matters, but maybe we have the word cat, but we're not going to use all 3 letters, okay? So when you have a number of permutations of n objects, but you're only going to use r of those. In other words, you're going to use less than the original number you had, then you have a formula for permutations. It's the total numbers, the ones you're going to use, how many of those total you're going to use. And so it ends up being n factorial over n minus r factorial. So for example, let's say that we have the word cat, but we're going to use 2 letters, and we want to know how many different ways can I arrange 2 of the 3 letters of the word cat. So here I have 3 letters. I'm only going to use 2 of them. So when I go to solve this, I'm going to have 3 factorial at the top and then 3 minus 2 factorial at the bottom. So 3 factorial over 1 factorial. And so how do I solve this? Well, I actually do 3 times 2 times 1, right, over 1. And again, the 1's cancel. 3 times 2 is 6. So there's 6 combinations for 2 of the letters of the word cat, 2 possible combinations. And even though those solutions, they were both 6, it's not always that way. So we'll do some more examples here. So again here, let's do some more examples of permutations. We have, again, in how many ways can you arrange? So this is order matters. Okay, when they say how many ways can you arrange those letters, order's going to matter. The letters in the word mouse. Now notice there's 5 letters. So there's 5 letters and we're going to use all 5. So this is a basic permutation of 5 factorial. So 5 times 4 times 3 times 2 times 1. And I get 120. So there's 120 ways to organize the letters in the word mouse. Now, here it says, in how many ways can you arrange? Again, order matters. Okay, so we're still at using permutations. 3 of the letters in the word orange. So N is 5, because there's 5 letters in the word orange. But since I'm only going to use 3, R is equal to 3. So when I set this up, it's going to be 5 and 3. So again, the formula is N factorial over N minus R factorial. So N is 5 factorial over 5 minus 3 factorial. So as I do my work, N factorial over 2 factorial. And so I can do this 2 ways. I'm going to show you a shortcut, but the first way is 5 times 4 times 3 times 2 times 1 all over 2 times 1. And what you're going to notice is the 2 at the bottom and the 1's can cancel. And you're just going to get 5 times 4 is 20 times 3 is 60. So there's 60 ways to organize 3 of the 5 letters. Now, another way I could have done it is I could have done 5 times 4 times 3. And once I got to what this denominator was, the 2, I could have just left it as 2 factorial. And that would have canceled, leaving me again with just the 60 ways like that. Okay? And so that's how we set up permutations. Here's one more. Your band has written 12 songs, so N is 12. You plan to record 9 of them for a CD, so R is 9. In how many ways can you arrange the songs on the CD? So order matters, right? So since order matters, we're going to do the permutation. There's 12 total songs, but we're only going to use 9 of them. So it's going to be N factorial over N minus R factorial. So this is going to be 12 factorial over 12 minus 9 factorial. And so again, I just kind of, set up my math here. And I do 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3. And before I keep going, notice that I have 3 factorial at the bottom. So I can, instead of doing 3, 2, 1, I can stop at 3, make it the factorial, and these would cancel. So my answer is going to be whatever this product is of all those numbers. 79, 833, 600. That's what it ended up being. Can you imagine? That's how many ways I can arrange 9 of the 12 songs on this CD. Okay? And again, yes, there is a feature on your calculator that actually does 12 factorial divided by 3 factorial. And we'll practice that in class. And then again, in example 3. For a town parade, you'll ride on a float with your soccer team. There are 14 floats in the parade, and their order is chosen at random. Find the probability that your float is first and the float with the school chorus is second, and the school's second. So now this is different. This is a probability question, right? This isn't just how many ways can something be done. It's an actual probability of a situation, but order matters because of the 14 floats, right? We want our float to be first and the chorus to be second. So this is where this gets a little tricky, and I want you to make sure that you kind of memorize the process. So in step one, you're going to find the total possible outcomes of this all, right? So again, for probability, remember that that total possible outcomes is going to be your denominator, right? So the total possible outcomes, there's 14 floats, or basically arrangements. So it's going to be 14 factorial, okay? Step two is to figure out favorable outcomes, okay? And what you do is you kind of think about, because that's going to be your numerator, right? And you sort of think about the fact that if you are first and your school chorus is second, that's going to leave the other 12 floats in the parade for the back end of this thing, right? You're going to be one, your chorus is going to be two, and then there's going to be 12 left on the back end. So we're going to find the permutation for that. So I guess I should have written for this one, it would be, 14 permutation like that, and it'd be 14 factorial. And for the remaining, for the favorable outcomes, it's going to be that all the rest of the floats fall in their order, 12 out of 12, and it's going to be 12 factorial. And when you do a probability, you're going to set it up as a probability. You're going to do your favorable outcomes over total outcomes. Now here is where we do our little trick. Instead of writing it out, since 14 is bigger, we'll do 14 times 13 times 12 factorial. I don't really have to do, write 12 all the way and 12 all the way, because those are just going to cancel each other out anyway. So what I do is I take the 12 at the top, 12 factorial and 12 factorial there. So notice that my probability is 14 times 13, which is 1 over 182. And this is the probability of us coming first, my friend, the chorus coming second, and then everybody else coming last. If I want to write it as a decimal, it's 0.005 or 5%, no, 0.5% probability that that's going to happen. So now we go to, I guess there's still more examples of permutations here. And soon after this, in the next slide, we're going to get to combinations. So again, here, find the number of ways you can range all the letters of the word boundary. Notice there are 8 letters, and then 3 of the letters of the word. So here is where R is 3. So the first part of this question wants me to do a permutation with all 8. So it's just going to be 8 factorial. So it's going to be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And it's going to be 40,320. And then the second one, where I'm only going to organize 3 of them, is going to be N is 8 and R is 3. So it's going to be 8 factorial over 8 minus 3 factorial. So 8 factorial over 5 factorial. So it's 8, 7, 6, 5 factorial over 5 factorial. So it's going to be 8 times 7 times 6. It's going to equal 336. Whoops. And so that is the answer to this one. Okay, so again, just be careful. Are you using all 8? And in that case, it's this one. Or are you using only some of the 8, and then therefore it's this one? Okay, so I'm going to kind of erase this and keep going. So we go to evaluate this permutation. So again, N is 6 and R is 3. So it's going to equal 6 factorial over 6 minus 3 factorial. So 6 factorial over 3 factorial, which is 6, 5, 4, 3 factorial over 3 factorial. These cancel. So 6 times 5 is 30, and 30 times 4 is 120. So 120 ways. Again, here we keep going. 14 factorial over 14 minus 9 factorial. So 14 factorial over 5 factorial. And again, it's just very repetitive. 14, 13, 12, 11, 10, 9, 8, 7, 6, 5 factorial over 5 factorial. Obviously, those cancel. And now I have to go to my calculator and multiply from 14 all the way down to 6. So I get 726485760. And then we just keep going. And the last question, there's 8 students auditioning for the main role in a school play. So N is 8. The order of the student auditions is chosen at random. Find the probability that you are chosen first and your friend Precha is chosen second. Okay, so there's going to be, again, it's a probability question. So total outcomes, right, is going to be 8 permutation 8. So it's going to be 8 factorial, right? So these are all the possible outcomes. Then we've got, if you and your friend get picked, then there's 6 left. And so now you're going to find favorable outcomes. And that's going to be 6, like this, permutation of 6. So it's going to be 6 factorial. So your probability is going to be the favorable outcomes over the total possible outcomes. So you're going to leave the 6 factorial at the top, and you're going to go 8, 7, and 6 factorial at the bottom. These will cancel, and you'll get 1 over 8 times 7, or 56. So it's 1 over 8 over 56 is your probability. So now we get to combinations, and you're like, oh, wow, something else. There's a lot of slides from this lesson. So this is when you're selecting objects in which order is not important. Okay, so in other words, you're just picking, you're just organizing the letters. It doesn't matter the order, or you're picking things and it doesn't matter the order. So for examples, an example of this might be when you're drawing for identical prizes. So for example, a permutation matters. Let's say you have first, second, and third place prizes where they have different values. So obviously it matters if you come in first or second or third because the prizes are different. But if you're just drawing and you're saying, I'm going to have 3 winners and everybody's getting the same prize, then order doesn't matter. It doesn't matter if you get picked first or third, you're still getting the same prize. So when order doesn't matter, we use combinations, which is a little bit different. So for example, if we want to know what are the possible combinations of 2 letters from a list of 4. So we're going to use combinations. And again here, N is 4 and R is 2. So it sort of looks the same, and you're like, okay, well, what exactly do I do differently here if I have 4 and 2? So the formula here is a little bit different. The formula here is N factorial over N minus R factorial times R factorial. So I just basically have this extra thing here at the bottom. So if I'm doing this problem, it's going to be 4 factorial over 4 minus 2 factorial times 2 factorial. So let's kind of write it out. I've got 4 factorial, and then 4 minus 2 factorial is 2 factorial times 2 factorial. Now you can't just multiply them and just do like, oh, 2 times 2 is 4, so it's 4 factorial. It doesn't really work that way. So you have to actually do 4 times 3, and then I get to 2 factorial. Notice I have two factorials at the bottom. So yes, I could cancel those, so I'm left with 4 times 3 over 2 times 1. So it's going to be 12 over 2, and my answer is going to be 6. So there's 6 possible combinations of 2 letters that I can make from A, B, C, and D. Okay. And here's the formula that I just used there. So it's the same thing we just talked about. Now let's keep going. So let's do some problems. You order a sandwich at a restaurant. You can choose 3 side dishes from a list of 8. How many combinations of side dishes are possible? Now again, it tells me combination, so it makes it easy. Again, it doesn't matter the order of your sides. They're all going to come on your plate. Basically, you're just picking from 8, you're picking 3. And so again, you're going to do 8 factorial over 8 minus 3 factorial times 3 factorial. So 8 factorial, 5 factorial, and 3 factorial. So 8 times 7 times 6 times 5. And as soon as I find a factorial that matches, I'm going to stop there because I know I can cancel those out. So at the top I have 8, 7, and 6. And at the bottom I have 3, 2, and 1. Now, if you could not use a calculator, then what I suggest you do is simplify now, because now these are factors. So like 3 and 6 share a factor, so I could simplify that. and the 2 can cancel. And then notice that my thing is 8 times 7 is 56 over 1. And so my answer is 56. So if I don't want to actually type in those numbers and multiply them, I can simplify first and then multiply. All right, so a yearbook editor has selected 14 photos, including one of you and one of your friend, to use in a collage for the yearbook. The photos are placed at random. There is room for 2 photos at the top of the page. What is the probability that your photo and your friend's photo are the 2 that are placed on the top of the page? So here, because I'm looking for a probability, remember that I want my favorable outcomes, right, over my total possible combinations or outcomes, okay? So I'm going to have to start by finding out what are my total outcomes. And so if I've got combinations, there's 14 photos and they're in pairs of 2, how many combinations or pairs of 2 can there be? So again, I'm going to do 14 minus 2 factorial times 2 factorial. And again, we do 12 factorial, 2 factorial, and I start counting down until I get to 12 factorial. Since I have a 12 factorial at the bottom, I'm going to stop there and cancel it. So I've got 14 times 13 over 2 times 1. And so when I do the math, it's going to end up equaling 91. So there are 91 possible total outcomes of combinations of 2 photos. Now, so that's my denominator. Now my numerator is the favorable outcomes. Well, how many opportunities are there for, out of all those combinations of 91, how many of those combinations is going to be me and my friend? Well, we're going to be one of those combinations. And so the probability is 1 out of 91. And again, you can leave it as a fraction. Okay, you don't have to worry about converting it to decimals and percents, but that's how you would do that one. So again, you actually do find the number of combinations, that's at the denominator, and then how many of those combinations are what you want. And in a lot of the examples we're going to do, it's going to be 1 in the numerator spot. It's not always 1, but it's going to be 1 a lot in the ones we do. So again here it says, your teacher randomly chooses 2 out of 18 students to give an impromptu debate on freedom of the press. What is the probability that your teacher chooses you and your best friend? Well, first, how many possible combinations of 2 students out of 18 is there? So 18 total, you're picking combinations of 2, and so we have to first figure out this, which would be our denominator. So 18 minus 2 factorial times 2 factorial. So 18, 16 factorial, 2 factorial, 18, 17, 16. Stop there. 16 factorial and 2 factorial. These cancel. So I get 18 times 17 over 2 times 1. And like I told you before, you could simplify a little bit if you don't have a calculator to make it easier. You end up getting 153. So there's 153 possible outcomes or possible combinations of 2's. So that's my denominator. And then you want you and your best friend to be the ones that are picked. Well, there's only going to be one possible combination that'll have you and your best friend as being the 2 people. And so the probability is 1 out of 153. Again, if this is just evaluating, again, this is, I know it looks weird, but it's, so n is 10, and 8 out of the 10 are being chosen. And so you do again, it gets very repetitive. Once you get used to it, 8 factorial. So we get 10 well, let me just do it that way. 10 factorial over 2 factorial, 8 factorial. So 10, 9, 8 over 2 factorial times 8 factorial. These cancel. So 10 times 9 over 2 times 1. And again, I can simplify a little bit. And 5 times 9 is 45. And so I end up with 45 possible combinations And again, we get to this last one on this page. Again, 24 and 10, so n is 24. And then we get 24 minus 10 factorial times 10 factorial. So 24. 24 minus 10 is 14 and 10. And again, I have to do 24, 23, 22, 21, 20, 19, 18, 17, 16, 15, 14 factorial finally, and then I have 14 factorial and 10 factorial. So I start there. Now, sometimes they don't let you use calculators for this. So 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. I can swap out the 10 for the 10 factorial for that. And if you're not allowed to use a calculator, then you can kind of start simplifying the 10 and 20, right? The 2 and the 2 there. I can take the 9 and the 18. I can take the 8 and the 16, right? I've got the 7 and the 21, the 6 and the 24, the 5 and the 15, right? The 4 and the, anything I can do here? No, the 4, I can take a 2 out of it. That I can do an 11. The 3, I'm not seeing anything, and the 1. So I might be able to do a little bit now, maybe this 2 and this 4 there. So I'm just simplifying, guys. So I see that at the bottom I'm left with a 3 and a 1. So my denominator is going to be 3. And then I've got the 2, the 23, the 11, the 3, the 19, the 2, the 17, the 2, and the 3. I don't know how much easier that is. Obviously, I think maybe it would have been easier to just grab a calculator. But if you can't, use it, and on a test you have no calculator, you can at least simplify, okay? And when I do all that math, believe it or not, I'm going to get 1961256. So that's the possible combinations of 10 things out of 24. Is an awful lot of combinations. So again, the combinations are not hard. You want to remember the formula. So for combination, you want to remember that it's going to be n factorial over n minus r factorial times r factorial. And for the probability questions, most of them, it's going to end up being some number over that, like 1 over that answer, okay, or whatever. Not always 1, but a lot of the ones we're doing are definitely 1.